Hello, everyone. Today, I decided to create a GPT-3-powered voice assistant with Python. I'm going to show how you can do the same, and at the end, we will give some ideas on how to take this program and make it into a software-as-a-service business. We will be diving into the code step by step and explaining what each line of code is doing, so even if you're new to Python and AI, you'll still be able to follow along. First, open your Python environment and create a new Python file. We will begin by importing the OpenAI library, which will allow us to access the GPT-3 API. Next, we'll import the PyTTSX3 library, which will allow us to convert text to speech. We will also be using the speech recognition library to transcribe audio to text, so let's import that as well. Now that we have imported the necessary libraries, we can set up our OpenAI API key. This will allow us to access the GPT-3 API. In this line of code, replace the dummy API key with your own OpenAI API key, which you can get from the OpenAI website for free. With our libraries imported and our API key set up, let's set up our text-to-speech engine. Here, we create an instance of the text-to-speech engine using the init method. This instance is stored in the engine variable, which we will use later to generate speech from text. Now let's create a Python function to transcribe our voice commands into text for our Python program to understand. We will transcribe audio to text using the Python speech.recognition library. Start by defining the transcribe audio to text function. This line defines a new function called transcribe audio to text and specifies that it takes a single argument, file name, which represents the name of the audio file that we want to transcribe. Now let's create an instance of the recognizer class from the speech.recognition module. This object is a requirement to perform speech recognition on the audio file. Next, we use the with statement to open the audio file specified by file name using the audio file class from the speech recognition module. Then we record the audio using the record method of the recognizer object. Finally, let's transcribe the recorded audio to text using the recognize Google method of the recognizer object. If an error occurs during transcription, an exception will be raised, and a message indicating that there was an error and the program is trying again will be printed. This handles unknown speech errors from Google. If our program records unintelligible sounds, and that's it, this function takes an audio file as input and returns the transcribed text. Moving forward, we will create a function to generate responses from the GPT-3 API. This line defines a new function called generate response and specifies that it takes a single argument, prompt. The prompt argument represents the input text that we want to use as a starting point for generating a response using the OpenAI GPT-3 API. Now let's use the OpenAI completion .create method to generate a response based on the given prompt, as shown in the OpenAI documentation for GPT-3. In this line, we pass several arguments to the OpenAI completion. Create method to specify the parameters of the response. For example, we specify the engine as the GPT-3 model by inserting text DaVinci 3. Then we set the max tokens variable to control the number of characters a response from GPT-3 is limited to. 4,000 is the max we can do with the DaVinci 3 engine. We can set the limit lower if desired for development to increase query speed, and then adjust it back to 4,000 when we have finished developing and are ready to publish our program. For now, let's just set it to 4,000 to see what the API is capable of. The temperature variable in the OpenAI API is a parameter used to control the creativity or randomness of the generated text. A temperature of 0.5 is often a good starting point as it balances the trade-off between predictability and creativity in the generated text. Here, we return the generated response from the GPT-3 API, and that's all. We now have a function to establish a connection with OpenAI so we can later call upon this function to communicate with the GPT-3 API. Let's create a simple function for speaking our responses from the assistant so it is 100% voice interactive. First, we will define a function called speak.text, which takes a text argument. This function will convert the text argument to speech using the PITS XX3 library. In this function, we use the engine, method to specify the text to be spoken and the engine run and wait method to play the speech. Now that we have set up all the prerequisite functions, let's start structuring the logic of how we want Python to run this script. Let's create a main function to do so. Next, we'll add a while loop that will run continuously until the program is stopped. The while true statement means that the loop will run until we force the program to stop in the terminal. This will allow our program to listen, answer, and then continue listening. Now, let's add a message that will be displayed on the screen to instruct the user to say hello. This line prints a message on the screen that instructs the user to say hello to start recording their question. Hello will be our prompt command to make our program start recording our question. We'll use the SR microphone class to access the microphone and record audio. Let's create an instance of the SR Recognizer class that we can use to transcribe audio to text. Let's now record audio using the listen method of the Recognizer object. Now we'll transcribe the recorded audio to text using the Recognize Google method. This line checks if the transcribed text is hello. The lower method is used to convert the text to lowercase to make the comparison case insensitive. If the transcribed text is hello, let's record more audio. This code block records more audio and saves it to a file named input.wav. The print function is used to display a message instructing the user to say their question. Next, let's transcribe the recorded audio to text. This line transcribes the recorded audio to text using the transcribe audio to text function. Now, let's check if the transcription was successful. If the transcription was successful, the text variable will contain the transcribed text. Next, let's print the transcribed text. Now let's generate a response using the generate.response function. Next, let's print the response. Finally, let's read the response using text-to-speech. Let's wrap up our try loop with this exception message. Except statements are used in Python to handle errors and give us control of how we want our program to respond to a given error. Without except statements, errors will simply cause a Python script to stop running. The basic idea behind using a try-except block is to attempt to execute a block of code. And if any errors occur during the execution of our try statement, Python will respond as we tell it to in the except statement. Overall, using try-except statements can help make our Python programs more robust, resilient, and easier to debug. And that's it. This is the complete main function that runs the voice assistant. Finally, we add the following code to the end of the script to run the main function. With these additions, our personal assistant is complete and ready to use. Now let's test out the script and see how it works. Let's run it using the Python GPT Voice.py and say hello in the microphone. After we say hello, we can ask a question. For example here, what is Python?
Python is a high-level, interpreted, general-purpose programming language. It is an open-source language that emphasizes code readability, allowing developers to express concepts in fewer lines of code than other languages. Python is often used for web development, scripting, data analysis, and artificial intelligence.
Pretty much that's it. I hope you enjoy it. You can continue playing with it all day around. Don't forget to subscribe and hit the like button. Have a good one. Bye.